Introduction to Inventory Management. In topic 2, we defined 5 reasons to keep inventory. They were pipeline inventory or work in progress, seasonal inventory that we might want to build up for seasonal demand or that we might have due to seasonal harvest, for example. We also defined cycle inventory, decoupling inventory. Decoupling is a buffer that we might want to introduce between different process steps to separate the processing and let them work independently, and safety inventory. And we also said that sometimes more than one reason applies, so some inventory might be called both one and another type. In this part, we will focus on 2 types of inventory, cycle inventory and safety, and we will focus on how we manage those 2. Cycle inventory occurs when several flow units are processed collectively due to economies of scale, for example, in batch production or in transportation. The objective normally for this decision is to minimize costs, and the 2 main components of the cost are fixed cost per order and cost of holding. And the main decision that we have is how much to order, what should order quantity be. And I have here in this picture on the right 2 possible inventory patterns. So you see, if we order a larger quantity, then when we receive the order, we have an increase in inventory level, and then we consume the inventory. It is dropping, assuming that demand is constant at a constant rate. We will be basically decreasing linearly the inventory at a certain rate, depending, right, on the slope here depends on the rate. And again, when we order another quantity, Q will use it and so on. If we order smaller quantities, assuming again consumption is at the same rate, the pattern is actually differs in a sense that the amplitude, how high the inventory is now much smaller due to smaller quantities, but also we receive the orders more frequently. So this quantity is around 3 times smaller than this one, and therefore for each cycle here, we have actually 3 cycles here, right? The decision that we're making about the order quantity affects then how frequently we order, and that will affect the cost of ordering, because there is a fixed cost that we assume for every order. So there will be 3 times more ordering cost here. However, it will also reduce the cost of holding because we hold much less inventory, 3 times less inventory on average is held here compared to this situation, and therefore the cost of holding will be reduced. So we have the decision where we decide the quantity based on those 2 costs and balancing those 2 costs. Now, one comment on the quantity, I'm assuming here that we will be always ordering the same quantity, not changing it, right? And that assumes that the conditions of the decision do not change. So if I have certain fixed conditions, it only makes sense to order the same quantity, either, for example, this one or another quantity, but we should not change it from 1 month, let's say, or from one period cycle to another cycle, because if the conditions are such that a certain quantity is optimizing our situation, it should also optimize it in the future. Now, of course, in realistic cases, the conditions might change, and then we might want to recompute or recalculate some of the models that we have and find the new optimal order quantity for the new situation. In addition to cycle inventory, one type, we will also be discussing or focusing in this topic on safety inventory. Safety inventory has a different reason. It is introduced in order to hedge against uncertainty in the underlying demand. So it assumes that demand is somewhat stochastic or random, right? Even if you sell something in a supermarket, and if you sell a lot of a product, there will be days when you sell more and other days where you sell less, or even the demand can vary from 1 hour or 1 minute to another. And so we will introduce the safety stock for which the symbol will be SS, right? And The trade-off here is mainly there's an extra cost of holding because the safety stock will be additional inventory, right? In addition to the cycle inventory that we have here, Q down to zero, Q down to zero in an average case, we will also have the safety inventory, and safety inventory in our models will be assumed to be held all the time. In an average case, it's an inventory that is kept all the time here, and it is the reason for it is if at some point the demand picks up, increases for a short time, and then this line drops at a faster rate, we want to avoid a stock out, meaning running out of inventory when there is demand. So the balancing here is between the cost of holding and the service level, right? If you have a stock out, then that's something that is perceived negatively by customers. And so therefore we will have certain service levels that we can define, and two typical service levels in inventory management are in-stock probability, which basically says the probability of not having a stock out, right? And this probability is defined for each cycle. What's the likelihood there is a stock out probability? What's the likelihood that the inventory drops to zero and there is still additional demand before we receive another shipment, another delivery, right? So in-stock probability would be 1 minus would be probability of not having the stock out. The other measure is fill rate, which is calculating the percentage of demand satisfied immediately. So if, of course, if there is a stock out, right, we might lose some demand, or we might have this demand satisfied with a delay. In a supermarket case, for example, if you don't find your product and decide you go to another shop to buy it, then from the perspective of the first shop, this is a lost demand. But in some cases, for example, let's say if you call a supplier of a product, business to business operation, and they tell you we don't have it at the moment, but we will have it in a few days, and then we will ship it to you, then this is still not satisfied immediately. Demand that is not satisfied immediately. However, it is satisfied with a delay. So, right, the demand will not in fact be lost, but a fill rate will be affected negatively by this definition. Two types of costs that will affect our decision on the cycle inventory, and also at least one of them will affect our decision on safety inventory, are holding costs and ordering or setup costs. Holding cost is composed of several types of costs. One is related to capital. Capital is an opportunity cost of capital, meaning that if you say, let's say, if you take a loan and you pay certain interest, that interest, right, which is usually a percentage of the value, can be considered a cost of inventory, of holding inventory. Because if you could hold less inventory, you could take a smaller loan and save yourself the cost of interest. However, sometimes you can take a loan to a limited extent, and then maybe you have other opportunities to invest that loaned money, or maybe you have your own capital that you could invest in something else instead of increasing inventory levels. And this is what we call opportunity cost of capital. In that case, for example, even if you take a loan on 10%, but then you have an opportunity to invest in something that potentially could bring you 20% of return, then inventory cost can actually be considered 20% of the inventory value, because by keeping more inventory, maybe you're losing the opportunity to earn 20% with the same capital that you're using for the inventory. The other type are operating expenses of holding inventory. These are usually related to like maintaining warehouse equipment, paying your salaries for labor, or some other types of costs. These are usually harder to allocate as percentage of inventory value because they are independent of the volume that you move through, let's say, a warehouse. For example, if you have a several number of workers, some workers in your warehouse, you pay their salaries regardless of the number of units that you move through the warehouse or the number of units that you hold in the warehouse, right? You have to pay the salaries. And so if you let's say, move a lot of units through the warehouse, you could allocate a smaller percentage for each unit if the number of products moved is small, then you have to like increase the holding cost. So it's actually hard to allocate independent on some parameters of your system. The third type of cost is lost revenue, and it includes some things like obsolescence, loss of value of the product, depreciation, real market value and depreciation or deterioration, like for fresh goods, shrinkage, and also insurance. These costs usually are easier to allocate in terms of percentage of value because, for example, insurance is often paid as right. If you buy insurance, you pay a premium that is usually a percentage of the value of the products. Most models assume we have a holding cost H, which is dollars or some other currency per unit of product per unit of time, right? And we assume it is constant, so we have to have somehow all these potential holding costs aggregated into one number. The second cost that affects our inventory decisions is ordering or setup cost. Ordering, of course, is used, the ordering cost, we term it in when we have delivery. In production settings, we more often call it setup cost. In delivery, the ordering cost will include things like supplies, forms, order processing, and other clerical support. It will also include things like shipping cost, unloading cost, etc. Anything that is fixed regardless of the quantity or paid once for each order. And in production, there could be several reasons to have cost. For example, there could be some cost to prepare a machine or process for manufacturing another order quantity. It could be also, in some settings, scrapping a certain part of production after setup. It might be that if you produce a large number of units on certain types of machines, you have to scrap the first X units that you produce initially because maybe they have insufficient quality or they are just not ready or not useful to be sold as final products or finished products. There could be also cost of renting a resource, but this should only be counted as an ordering cost if you actually pay only for the duration of using the machine. So it doesn't apply to a case where you rent, for example, continuously the machine and you pay for the rent regardless whether you use the machine or not, then you shouldn't consider this a cost of setup. But if you, let's say, rent the machine for a number of hours and then you can return it after you stopped using it, then the cost of renting for the time of the setup could also be considered the cost of setup. Most models assume we have an ordering or setup cost K, which is constant and it is independent of quantity. And again, sometimes we have problems defining this as a constant. And a good example is shipping cost, which often depends actually on the quantity. The larger the quantity, some shipping companies will charge you a higher cost, for higher price for shipping. They might have thresholds, and if you exceed a certain threshold, the price goes up.